Learning activities labeled as constructivist have been controversial. There are some who believe such learning activities are the best way to prepare students, and others who see the approach as unproductive and ineffective, especially for less capable learners. One approach to evaluating the general claim that these methods are not productive might be to identify just what these methods are, and then to consider whether a specific example of a category is a good example. Following this logic, we then place particular value in the data that are available when good examples are implemented. Our focus here is on activities described as problem-based learning. While our text presents student learning experiences we believe are good examples of problem-based learning, many of our examples are probably more accurately described as projects. Both are often included as constructivist learning activities. So let's try to differentiate problem and project-based learning. Understand these comments represent our impressions, and others may offer a different interpretation. First, it would seem these learning tasks can be differentiated on the basis of the goal presented to the learner. Learners are encouraged to think in terms of the task assigned. So some tasks assume students will learn in order to solve a problem, and other activities are based on the assumption that students will learn in order to generate an artifact, a product, or a lesson to inform others in our model. In project-based learning, the learning process begins with the description of the artifact learners are to generate following their development of personal understanding. Learners must develop knowledge and skills in order to eventually generate this artifact. They prepare themselves to create a multimedia document, or perhaps to teach someone else. Problem-based learning begins with a specific description of the problem to be solved and is often set within a scenario that provides a context for that problem. What is your recommendation for what should be done in this situation? So are these tasks really different? Well, it depends. The artifact in project-based learning could be the proposed solution to a problem. But this would not have to be the case. The artifact could take other forms. Our focus on authoring and teaching to learn would be more frequently implemented toward the project end of a project-based to problem-based continuum. Asking you to develop a multimedia explanation of photosynthesis may technically represent a problem for you if you have poor background knowledge, but the task is presented to you seeking an explanation rather than your argument for a problem solution. We suggest that the processes involved in problem-based learning and project-based learning place a different degree of emphasis on the activation of what students already know. This seems to be the case for at least some strategies for problem-based learning that researchers have demonstrated to be effective. Most models of learning argue for the importance of existing knowledge and learning, but seem to differ in how, and probably actually if, this existing knowledge is purposefully activated. Critics of constructivist activities appeal to what is known about human cognition and point to problems with working memory overload and the nature of the cognitive architecture. We explain these terms in details elsewhere, but the topic of cognitive architecture applies here. We take this phrase to mean how thinking and learning happen. The assumption is that the hardware and the software, the processes of the system, work a certain way, and these limitations or affordances, depending how you want to conceptualize the system, cannot be ignored if optimal performance is expected. One complaint leveled against constructivist activities contends that inexperienced learners with poor background knowledge have a great difficulty learning when exploring on their own. They do not have the existing knowledge to interpret their new experiences. New experiences can be confusing and lack an existing context for interpretation. There is a different way of looking at, however, what happens when learners confront a problem. I have been following the research of Kuhn and colleagues, and here is how they define problem-based learning and make nearly the exact opposite argument regarding cognitive architecture. These theorists claim that in problem-based learning, quote, students engage a problem without preparatory study and with knowledge insufficient to solve the problem, requiring that they extend existing knowledge and understand in generating a solution. End quote. Their definition does raise the existing knowledge challenge, but they see growth resulting from the activation of knowledge that is inadequate. Kuhn argues that the assumption learners must start from scratch with direct instruction ignores what we know about cognitive architecture. Effective learning begins, in this perspective, with the activation of what learners already know. In other words, you cannot just explain something to someone with little existing knowledge if you really expect them to understand. You must activate whatever relevant knowledge they have and then build on that knowledge. In Kuhn's approach, the role of the problem is crucial, and Kuhn expects learners to struggle with the problem without the contribution of new information in order to activate existing knowledge. The challenge, in fact, is creating a problem that will engage the learners in this struggle. Kuhn and colleagues use a strategy that moves learners through the following experiences. Problem presentation. Students are given a scenario within which is embedded the problem. A request of students to identify core problem issues and discuss what might be done. This is the struggle based on existing knowledge. Focused instruction. There is an effort to offer new but focused information in Kuhn's model. Hence, this is not pure discovery learning. Finally, further discussion among a small group of students. Students again address the problem, now with some relevant information, and then formalize a problem solution. An example may help. One of the problems used in the Kuhn research was designed to help students understand the challenge of groupthink. We understand this phrase to mean that good ideas within a group are sometimes held by a minority of the group or more junior members of the group, and the idea may not receive serious consideration as a consequence. Understanding this possibility, this limitation, can lead to countermeasures to improve group functioning. An example of a situation in which groupthink may have been an issue was the Challenger disaster. Supposedly, junior engineers had concerns, but these concerns were not given serious attention. Students can be put in a situation of considering this specific scenario as a way to learn about factors that influence group effectiveness. Instead of beginning with a presentation about group effectiveness, students could be presented this example, which they likely are aware of because it was such an significant news event, and then asked to recommend a change in policy to NASA. An important insight in understanding the problem-based approach as implemented by Kuhn and her colleagues is that students within small groups are asked to grapple with the problem before they are provided specific instruction. They can be asked to consider how the ideas of underlings within a group could be given more careful consideration before the concept of groupthink is explained to them. They can struggle with this question without being aware of the formal description of groupthink and explanations for why it happens. If you consider the stages in the instructional model, you can see how this model then might be applied. Consider how the same amount of time might be allocated with direct instruction and with this model. Some instructor-dominated time exists in the problem-based approach, but it is condensed and focused and is provided after students have struggled with a problem based on their existing knowledge and what might be described as their own common sense. According to Kuhn, the specifics of how the learning activity is implemented are very important. We find ourselves in the situation of trying to explain instructional strategies such as this to help educators imagine how they might go about engaging their students. The goal is not to have them teach the topic of groupthink, but to understand the components of the approach used so that the educators can generate problem-based tasks appropriate to their own curriculum. Providing a concrete model seems an appropriate approach in developing this understanding. We are constantly searching for ways to make useful but abstract ideas easier to understand. The components identified by Kuhn seem remarkably similar to Bernie Dodge's outline for WebQuests. Bernie Dodge and Tom March worked out the design for WebQuests at San Diego State in the middle 1990s. One of the things about WebQuests that has always been appealing to me has been that it seems such a concrete example of an abstract idea. I've always found it helpful to think of this design as content that appears on a single sheet of paper, or a web page if you prefer. The components of a WebQuest, at least as I understand a WebQuest, consist of the following: an introduction, which provides a scenario and kind of a short explanation to get the learner interested. The task, the problem that learners will be asked to solve. Resources, these are web resources. This is called scaffolding. So useful resources are identified for student use. These resources then usually include additional information that encourages a certain kind of process. What should be learned, what could be learned from each resource. And then finally, of course, the students generate the product, and there is an explanation of how that product might be evaluated. If we take the groupthink example I have already outlined, you might imagine this problem set within the WebQuest design. At the top of the page might be the picture of the Challenger exploding in air and a paragraph about the rocket design problem and the failure of the group of engineers to consider the possibility of a weakness in the launch vehicle. The task would be the challenge to offer a suggestion to NASA for a different approach to be used by the many engineers who worked on these complicated missions. A WebQuest then presents learners with links to carefully selected web resources and brief explanations of what they might find useful within each resource. If learners were asked to consider the task before reviewing these resources, the process of completing a WebQuest would be very close to the problem-based approach model proposed by Kuhn and her colleagues. Sometimes I think we move beyond good ideas simply because something new and shiny comes along. I have asked students in my own graduate course about this situation with WebQuests. What exactly happened to WebQuests? They seem less popular now than they were at one time. And what possibly could have been wrong with them? Two reactions surfaced. First, my students proposed that many WebQuest educators located were not of high quality. The idea here seemed to be that educators would find an existing WebQuest rather than create their own, and the ones they found were not appropriate or not effective. Many WebQuests were not developed around a problem beyond asking questions to look up some information online. In other words, these WebQuests were not really good problem-solving activities. Second, they proposed that practicing teachers found WebQuests to be so very popular and that a kind of saturation set in and students tired of them. The simple format they proposed seemed to encourage an interpretation of repetition. We propose you use WebQuests as a way to begin developing problem-based learning activities. The basic structure should offer a way to generate a learning experience for students and gain some experience with problem-based instruction. As you develop a feel for proposing learning tasks as problems, there is nothing that requires you to become locked into one way of doing things. What we think is important is that you make a start. These comments were partly based on my reading of the research literature. In our online materials, you can find relevant citations if you would like to examine this background more on your own.